All right, welcome to wasmCloud Wednesday for August the 4th. As usual, we're going to get started with the demo. Steve, I think you're on demo today. Okay, hand it off to you.
All right, thanks, Liam. Okay, I'm going to demo a few things. All right, I'm going to start with, start with the interface. So I'm gonna walk through an interface definition in a Smithy file, and then I'll show some of the code that gets generated from that, and then a HTTP server capability provider and a echo actor, and then we can try to run it and cross our fingers and hope it all connects. So this is a Smithy file for the HTTP server capability contract. The metadata at the top is mostly to give some hints to the code generation. Every Smithy file has a unique namespace. This one has a service called HTTP server, and this WASM bus annotation right above it attaches some attributes to this service. It has the contract ID, which is the capability contract, and actor receive is a directionality indicator that says this service is something that an actor would implement the handlers for the operations of this service. We can have an actor receiving or provider receiving or both. And this, so all the syntax here is defined by the Amazon Smithy. So we haven't done anything to change the syntax. In fact, we can use the built-in Smithy linter and validators that come with that tool set. But we can define annotations like this. So this particular service has one operation, HTTP request. I'm sorry, handle request, which has an input structure and an output structure. And these are almost exactly the same as they were for the wasmCloud 0.18. We made two minor changes. One is that in the HTTP response, status code is U16 instead of a U32, because we only need to store a 3-digit number. And the other change is that the map conforms to the HTTP spec a little better. Instead of a map of string keys and string values, it's string keys and an array of string values. And that's defined down here at the bottom, key string value header values, which is a list of, which is an array of strings here. Okay, I'm going to now show what that generates. So this is the Rust output. We've only implemented Rust so far, but we want to get some other interfaces. And this code that's generated here creates a library that's shared by providers and actors. So here's the HTTP request. Same fields. One thing you might notice here is that we always generate the field names for the structures in the idiomatic form for the target language. So the underscore, the snake case is what's used for Rust field names, but the name on the wire is the name that's declared in the Smithy file. So that should be consistent everywhere. And so this 30 flag tells the Rust compiler that. It also defines a trait. So if you remember that HTTP server service in the Smithy file had a single operation handle request. If there are multiple traits, they'd all show up here. And what this gives us is when you're implementing a handler, the compiler will give you the feedback that you need to implement more functions in that trait. So now I'll go to the, any questions about that so far? Okay, now I'm going to look at the HTTP server provider. So this imports that interface. Here's the place we import the request and response structures. We're looking here. Here's the main file. So capability providers, instead of being a .so library, it's an executable, which is part of what gives us the ability to run in any language. When main runs, the host actually starts up the capability provider as its own process, and the host passes to it on standard in a bunch of parameters it needs to connect to the lattice. And so inside this provider main, what happens is a provider main is a library function that we've built, so you don't have to implement it, but it subscribes to several of the NAT subscriptions for health checks, for the link definitions, and the shutdown message, and so on. And then it just hangs around waiting for a shutdown message. But you pass into it your implementation of the server interface, which is this HTTP server provider. Now on the provider side, one of the interfaces you have to implement is called provider handler. That has a health check, which I've commented out here because the default implementation always, which is built into the base trait, always returns healthy. Now, if your provider can do something more sophisticated as far as determining health of your service, other than being able to return a function call, then you could override that default implementation. There's also a put link, which happens when the host sends us a new link definition. And in this case, what we do with that is we spin up a new HTTP server listener on a port, on an interface and port defined in that link definition. Delete link says we're not connected to the actor anymore, and we stop that HTTP server, and then shutdown stops them all. So those are the 4 messages you need to handle as a provider. And then there's the interface specific stuff, which in our case is going to be respond to the HTTP request. So I won't go into that detail. I'll go over to the actor now. That's over here. So this is the entire code for the actor. Some of the code is handled by these magic of derived functions. But what we've done is we said we have to implement this HTTP server trait. So we have a handle request function to respond, and it takes a HTTP request parameter, returns the HTTP response. And what the echo actor does is it creates a JSON string of the input structure and sends that back as the body of the response. And we also implement a health check, which says, oh, actually, I'm not sure why, but I was probably testing the health request. It returns unhealthy. So that's the actor. Oh, go ahead.
I was just going to point out, like, I think we generate it so that if you're essentially going to auto implement the health request as returning healthy, then this is code you don't have to write.
That's right.
Awesome.
That's correct. Actually, there was one other thing I was going to show you is we've also made an effort to simplify the make files. I don't know if you're familiar with the old make files for the capability providers where you had to build the par file and all that. But here's the whole make file for the HTTP server. You define your variables, and then we've taken out the boilerplate code. So this wasmCloud release, and what we're all working really hard to do is get rid of boilerplate. So all those rules for building the par file, they're all the same for every make file. So we just put that into a common file. All right, so now I'm going to go to the host. One thing I have done is, because we haven't yet implemented the wash commands or a manifest file, I actually created a manifest file in Elixir. And so this is a workaround that I came up with on my own, where I have an array of actors, an array of providers, and then an array, and then the link definitions. So it's the same kind of content as was in the manifest from the 0.18 host. But that was my workaround. So so I'm going to start the host. Which is that, and then there's starting the actor and the provider. And it says that the HTTP server is listening on port 9001. So I'll go over to another terminal. And I curled the HTTP server port, and the echo actor has returned this JSON response. So there it all is plugged together.
So one other thing I want to point out here that we got sort of for free when we switched to using executable binary for capability providers is that there was no libc used anywhere in this example. So we no longer have to deal with the burden of trying to figure out how to build Docker images and runtime environments that have the right version of the C runtime on them, which was a huge pain in the butt for the 0.18 stuff.
I second that. Was quite painful.
So I think I just heard that wasmOTP can do that.
Yes.
This is amazing. It's really good.
Yeah, look, we went back and forth. I mean, Kevin, I felt like you agonized on this. The pain of making all these changes after all the feedback and experience we had with .18. And I know it's asking a lot of people to say that, we're putting in all this effort to do another big rewrite, the second big rewrite in a year, from the .18, or was it the .16 release that we'd done in December, where we moved to Actix, to understanding then and getting that experience, and then looking at this on the way out. And Steve, I really appreciate all the thought and perspective and leadership you've had on this particular topic. And the workflow is just so much more polished than where we were before. I think we're aligned now to an ecosystem that gives us the tooling and has this whole community, the Amazon has been driving that speaks to the scale for the vision that we have here, because ultimately we're going to need to be able to, have libraries of these things and, manage these APIs across hundreds of things in the future is the scale that we'd like to be able to build for. So great demo, Steve. I really liked it. Are there any other questions for Steve?
I was just going to point out that if he keeps demoing his Elixir workaround, that may just end up in production.
No,
All right.
whatever it takes to get it. If you have to open the Elixir book to get the job done, then that's what it takes.
Oh, that's hilarious. All right, awesome demo, Steve. Thank you again so much for the demo. Just a couple quick community notes. We have until August the 7th to get your submissions in for, or is it August the 8th, to get your submissions in for WASM Day. I really encourage you, if you have a submission, to pull it together and get it in. I would say we're a little bit behind where we were last year, or for KubeCon EU at this time, although we do have some really cool ones. Somebody has got is looking to run Doom in the database, which I think is that's part of a toy piece of their example. But there's some really cool stuff that people are putting together. I'm really excited about that, and we'll start doing some final calls here to get those out. So if you have any ideas, or if you have something, all levels of content, any ideas, a case study, Red Badger folks, exactly what you're doing and doing like a Kubernetes one, I think would be incredible. If you wanted to do this discussion that you guys just did here, if you guys wanted to pitch that, I would be super enthusiastic on that, because we are all thinking the same thing, and you guys are spending the time to work through the details and have so much valuable and powerful experience to share. So if you haven't pulled up together a submission, please do so and submit it, because I know that there is a large community of people that are thinking through this. And in fact, I may point a couple people that have pinged us, certainly at your repos, or maybe even try to facilitate some cross introductions along those lines. So please get those in. WASM time, bi-weekly meetings, still chugging along. Notes are linked in the doc. And then I think that's all I have on community. Anybody else have any other community stuff that they wanted to share? All right. Well, I think now, Steve, or Brooks, I'm not sure if somebody wants to pull up our sprint for the week and just give a call out to where we are and what's going on. Steve, I think you did it last week, with the Zen Hub board.
Yeah. Yeah. Give me a sec here.
If I had to do it, I would just have to ask you for screen sharing permissions, Liam, and I didn't know if you wanted that.
All right. I'll just give them to you anyway.
Oh, yeah, I can pull it up here.
Okay, go for it.
Oh, okay. So we closed 17 issues last week. So we got a good velocity here. The sprint backlog for this week, Kevin has been doing a lot of work on distributed cache and consulted with the NATS development team on the architecture for that. We are consolidating a bunch of functionality into into Wash CLI. So we're still going to have the Wash CLI, not the REPL. The REPL part is deprecated, but to be able to issue a bunch of commands, and we're also going to be using it for code generation from the Smithy models. And then a bunch of other consolidation. Really, the goal of this week at a high level is to get a buildable actor and capability provider and host, so that you guys can start playing with it and kicking the tires. And so sometime either end of this week or by mid next week, all of those things should be available. So you'll have code you can download and build and run. So that's where we are in the sprint.
Steve, last week we had talked about, some way we were researching some way that we could, automatically dump this into Slack on like a weekly basis or something. Did we look into the, paid version of Zendesk or ZenHub or anything like that? Or is there, some sort of report that we can generate after we do planning on Mondays?
Yes, there is some reporting that I've played with. I wasn't really crazy about it. So it's one of my tasks for this week is to figure out how to get the right reports out. So by the end of this week, I should have the answer to that.
All right, and then that's something that maybe we'll add to our agenda for Mondays, and maybe we could start just trying to, as we pull things together, dump out to Slack just to keep people up to date.
Yeah, we'll do. I'll dump some reports into the sprint planning Slack channel on wasmCloud.
All right, that's awesome. Any questions across the team, or Brooks, Kevin, anything you guys would want to throw in add here?
No, I think by next week, I'll definitely have more updates on what our solution is for the durable and distributed cache going forward.
Yeah, the only thing I wanted to call out, which I think is kind of cool, is like we have a lot more visibility here whenever somebody opens an issue in one of our repos. Whether or not GitHub decides to notify us, it kind of pops up right there in the new issues list, which is great. But
did manage to find a way to do this with GitHub Actions. But yeah, it doesn't do it by default. Like the GitHub Projects is terrible by default. And it took an awful lot of work to get even basic things like that working. So this ZenHub does look quite nice.
Yeah, sweet. One of the things that's neat about it is the issues are still in GitHub issues, so everybody can have visibility. But some of the metadata fields, if you think about it that way, like sprints and epics are in ZenHub and not GitHub, so that's why we need to write some scripts to pull those things together to make reports. But yeah, it serves the function. It's free for open source projects, and but reporting takes a little bit of script work.
Okay, super. Open floor, I guess. Any open floor items that anybody would want to bring up today? All the way across, I think we're covered. Okay, well, anything in closing? All right, well, we'll go and wrap it up here. I'll go and stop recording, and as usual, we can hang out. Cheers.